Question 80 is acid-base titration. Question 80. What volume of a 0.5 molar hydrochloric acid is needed to neutralize, let's say 88, I show you just a 1. Okay. What volume of a 0.5 molar HCl solution is needed to neutralize 10 milliliter of 0.3 molar. Let's show you B. B is more complicated. Okay. A is a little bit easier. A is a 1-to-1 ratio. B is a 1-to-2 ratio. Let's show you a more complicated one. 10 milliliter, 0.2 molar. Barium hydroxide. Any calculation related to reaction, you need to write a balanced equation, right? What is the balanced equation? Acid-base reaction. The acid is HCl. Base is barium hydroxide. 2 hydroxide, right? Then you need 2 hydrogen. Remember, any acid-base reaction is a 1 hydroxide reactor with 1 hydroxide, 1 hydrogen. Then BaOH2, you already have 2 hydroxide. Then you must have 2 hydrogen. Then produce 2 water. The rest is a salt. Right. So here, to neutralize 10 milliliter 0.2 molar BaOH2. So this base volume concentration are known values. From volume concentration, we can calculate the moles of this base, right? So 0.2 molar times molarity times volume in liter is moles, right? So here volume is 10 milliliter. We need to convert it to liter. And molarity times liter is moles. For moles of barium hydroxide, according to this balanced equation, we get moles of hydrogen, hydrochloric acid. So up to here, you get moles of hydrochloric acid. Then for more, how can you find the volume? So we need to follow this. Molarity M equal to moles of solute over liter of solution, right? So now we already get moles of solute. How can we find volume? So more divided by molarity, you get a liter. Switch these two because molarity here is a 0.5 molarity, right? 0.5. So moles divided by molarity, you get a volume. Molarity is 0.500. So moles of hydrochloric acid divided by molarity of hydrochloric acid, you get volume. That's volume. .008 liter or 8 milliliter. So this is your answer. So we need 8 milliliter of hydrochloric acid to neutralize 10 milliliter of 0.2 molar barium hydroxide. Okay. Are you okay with this? 88 easier. 88. The base is NaOH, is 1 OH. 1 they react with 1 hydrochloric acid. Then take a look at 72, which is a gravimetric analysis. We just learned, right? Anyways, the 9 o'clock class I already recorded, so don't worry. Something wrong in the response. Yeah. I don't know why. It's exactly the same as I showed in the 9 o'clock class. That's already recorded. 72. The concentration of sulfate in water can be determined by adding a solution of barium chloride to precipitate the sulfate ion. Write the net ionic equation for this reaction. The net ionic equation is we add barium ion to the sample water have sulfate in it. Barium react with sulfate, form barium sulfate precipitate. This is a net ionic equation. Treating 145 milliliter sample of water with excess barium chloride. This water sample contains sulfate there. We use this barium chloride provide barium ion. Form this precipitate, collect and dry, and when mass is 0.330 gram. Okay. So based on this data provided, RCU determines the concentration of sulfate in the water. RCU determines concentration of sulfate in water sample. Okay. Tell you mass. Again, when tell you mass, always think about convert more, because any reaction is a mole relationship, right? So 0.33 gram barium sulfate. How can we convert more? So that chart tell you divided by molar mass. Where you can get molar mass? Use periodic table, right? Periodic table. Barium 137.3, sulfur 32.06, oxygen 16, 4 oxygen. So 4 times 16 plus sulfur 32.06 plus barium is 137.3. So add all these together, molar mass is 233.4. Right, mass divided by molar mass, you get a moles. Then from moles of barium sulfate, based on this balanced equation, no number means 1, right? So in order to form one more barium sulfate, you must have one more sulfate. This more should be same. So here we get a more sulfate. Then can we calculate the molarity? Yes. More divided by liter. Right? What is a liter? You need to convert this into liter. 145 divided by 1,000 becomes 0.145, right? Move 3 decimal place. More divided by liter is molarity. On 0.00975 molarity. Okay, so we get molarity of sulfate. Now, are you okay for this? Yes? No? Okay. Yeah. Then take a look, 66. Oh, sorry. We can get it back. Let's jog it too. Okay. Mass divided by molar mass, get a moles. Then use this balanced equation from moles of sulfate, convert to moles of barium sulfate, convert to moles of sulfate. Then more sulfate divided by volume, so it's volume carry, convert milliliter to liter. You get molarity. Okay. Now next is 66. 66 is a dilution problem. Okay. We learned it today. Okay. You have 505 of 0.125 hydrochloric acid. And you want to dilute it to 0.100. Adding water to it. Ask you how much water should you add? Read again. What does it mean? You have 505 milliliter of 0.125 molar hydrochloric acid. You want to dilute it to final concentration is 0.100. And the question is, how much water should you add? Everybody know dilution problem solving, the equation is this, right? MIVI equal to MFVF, right? This is the equation you need to use. Everybody, you need to remember this equation for dilution problem solving. Okay. Then identify which one is MI, VI, or VF, or MF. Okay. What this two means? this initial concentration, right? Mi, this initial volume, Vi. What this is? Mf, yes. So MIVI, MF. So you can definitely calculate VF, right? So from here, VF equals to M by VI divided by MF, right? Both sides divided by MF. Now just plug in the number. MI 0.125, VI 505 milliliter, MF 0.1, and molarity cancel left over milliliter. Your VI is milliliter, then VF also milliliter. So from here, we get the one number is 631.25 milliliter. What does this mean? Is this your answer? This is not your answer. So the question also is how much water should you add? This process is start with initial concentration. You add some water to it to the final concentration, right? The idea is VI add some water, water equal to VF, right? So your volume of water should be VF minus VI. The difference, you need to add water to there. 631.25 minus 505. 126.25 milliliter. So 505 initial concentration, initial solution at 126.25 water. You get the final volume 631.25. You need the second step. Okay. So during the test, you need to read the question carefully. What I asked. Okay. Let's say 39. Okay. 39. For the complex redox reaction, as you break down each reaction into half reaction, then identify oxidizing agent and reducing agent. Let's take a look just one example. Okay, the rest is similar. A. Strontium reacted with oxygen gas produces strontium oxide. Break down into half reaction. We have two reactants, right? So each reactant will be half reaction. The strontium oxide is an ionic compound. Strontium comes from group 2A, so always positive 2 charged ion. From free matter, 0 charge to positive 2. What does this mean?
Lost electron.
Yes, lost 2 electrons. Then 2 strontium lost 4 electrons. Right? And where these 4 electrons go? Gained by oxygen, right? So oxygen molecular gain 4 electrons becomes oxide. Okay. The half reaction lose electron we call half oxidation reaction or oxidation half reaction. The one gain electron, we call this reducing reaction. Then which one is oxidizing agent? Which one is the reducing agent? Either this or this. Cannot be product. Always one of the reactant. Right? So which one is oxidizing agent? Oxygen or strontium? Which one is a reducing agent? Strontium is a reducing agent or oxidizing agent? No. Reducing agent always matter. Always matter. Oxidizing agent could be non-matter or matter R. So for this case, reducing agent always matters. So this is strontium. Reducing agent lose electron, be oxidized. So strontium lose electron is oxidized. That's why this is oxidizing reaction. And oxidizing agent is reduced. It is opposite. Oxidizing agent is no matter or matter R. Here no matter R. Hey, don't care don't consider the product. The reducing agent or oxidizing agent always a reactant. Okay, so this is matter. This is no matter. No matter R here. So no matter is oxidizing agent. If we oxygen there, of course, this is oxidizing agent. This name comes from oxygen. Again, oxidizing agent is non-matter or metalloid. For this case, is a non-matter. Sometimes metal iron, like a copper iron reacted with zinc metal. Copper iron be reduced to copper. Zinc metal be oxidized as zinc iron. Okay. Okay, reducing agent always matter. Oxidizing agent could be no matter like here. Sometimes could be metal iron. Well, 2 minutes left. Let's show you one more. Number 9, ask you which of these substance is strong electrolyte, weak electrolyte, or non-electrolyte? Okay. Is it strong electrolyte, or weak electrolyte, or non-electrolyte? Strong, yes. This is soluble ionic compound. This is salt. Why is this soluble salt? Potassium there, right? Alkaline metal iron in the salt, in the ionic compound, always soluble. So this is a strong electrolyte. In water, break down the self, complete breakdown into potassium ion and chloride ion. What this is? Acid. This is acetic acid is a weak acid. Weak acid is a weak electrolyte. Water, very weak. Only 1 out of 10 million water molecule can break down into ions. Now what this is sugar. Okay, this is the sugar we normally eat. We normally add to coffee. Sugar is an organic compound. Can dissolve in water, but in water still is a molecular, no iron. This is non-electrolyte. Have in molecular form when dissolved in water. Okay. Spend some time during weekend. So Monday we will have quiz 4.